In this question, we are told that the function fx is defined as minus e to the power minus x, and we are asked to find the nature of the function. Now, fx can be written as e to the power minus e to the power minus x, which is equal to minus 1 by e to the power x. So, if I put the value of x equal to 0, then fx becomes minus 1 by e to the power 0 or minus 1. So if I plot this on x-axis, this is my y-axis. So at x equal to 0, y equal to minus 1, or fx is equal to minus 1. So minus 1, 0 and minus 1 is a point on this curve. So next we put x equal to plus infinity. So fx will be equal to minus 1 by e to the power infinity, which is 1 minus 1 by infinity, which is 0, and it is approaching from the negative side. So this curve will go like this, and since fx is equal to minus e to the power minus x, so if I put x as minus infinity or tending to minus infinity, so fx will be minus of e to the power minus of minus infinity would be plus infinity, which means fx will tend to plus infinity. Fx will tend to minus of infinity, which is minus infinity. So therefore, as x tends to infinity, fx tends to minus infinity. So the nature of this curve will be like this. So therefore, this curve will be a concave curve, because we decide the convexity or concavity of the curve by looking from downwards. So from downwards it is concave. So the function would be a concave function. In the next question, we are given a function fx defined by x log 1 plus x to the power minus 1 in the range of x lying between 0 to infinity, and we are asked to find the limit of this function as x tends to infinity. So we can write fx equal to log of 1 plus 1 by x over 1 by x. So therefore we can write 1 by x equal to z. So as x tends to infinity, z tends to 0. So limit fx as x tends to infinity will be equal to limit fz as z tends to 0, which is equal to limit z tends to 0 log of 1 plus z by z. Now we can see that if we put the value of z equal to 0 in this, then the function becomes of the form 0 by 0. So therefore we have to use L'Hospital's rule, and we have to take the differential of the numerator and the denominator with respect to z. So this would be limit z tending to 0 ddz of log of 1 plus z, and in the denominator we'll have ddz of z, so which is equal to 1 by 1 plus z over 1 limit z tending to 0. So this is equal to limit z tending to 0 1 by 1 plus z, which is equal to 1. So option 1 is the correct choice. In the next question, we are given the function fx is equal to root over x, and we are asked to find f inverse of fx. So here we have fx is equal to root over x. That means x is equal to f inverse of root x, or f inverse of, instead of root x we will write f of x. So therefore f inverse of fx is equal to x. So option 1 is the correct choice. In the next question, we are told that there are 6 horses that are running a race. How many different groups of horses could make up the first 3 places? So that means we have 6 horses, 1, 2, 3, 4, 5 and 6, and 4, 5 and 6, and the first position can be taken up by any one of the 6. So I can pick one from these 6 horses in 6 ways. So any one can be the first. Corresponding to that, we will be left with 5 horses because the first position is taken. So any one of that 5 can be the second, can come in the second spot, and any one of the remaining 4 can come in the third spot, and these are uh, interchangeable. That means this can happen in 6 into 5 into 4 by 3 factorial ways. So in other words, we can choose 3 horses to be in the first 3 spots in 63 ways, and that means that this is equal to 20 ways.